Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology turned podcast. Everyone, welcome into the program today. I hope that you're doing well and you're ready for today's show because it's going to be a great one. We have the one, the only Mr. Ralph Bond here with us, and we're going to be talking about a number of stories, and of course that number being 4. If this is the first time that you have joined us during one of these segments, you're in for a treat, because this is, of course, one where on a Friday, we want to send you packing with something nice, relaxing, fun, enjoyable. There's plenty of time to worry that the sky is falling later. This week, though, and today, we have 4 very fun stories. So stick around for those, and of course, that's with Ralph Bond, our science and tech trends correspondent. But before that, computeramerica.com, that's where you'll find everything, including the show notes. Ralph does an amazing job putting these things together. You should go check him out just to see his efforts. And of course, for anything that we talk about here on the program, the show notes will be the best place to find more information, because Ralph will kind of tell you what he does. But let's just say, hey, there's always more to find out. So with that being said, let's just go ahead and, let's see, computeramerica.com, social media links. I think we are ready to just, jump into it. So, as I said before, Ralph Bond, he is a longtime correspondent and, of course, has become our science and tech trends correspondent in particular. And what that means, you'll find out. Ralph, welcome back onto the program. How you been?
I'm doing great, and it's great to be back. And friends, if you're new to the show, welcome. What Ben and I do each Friday is look at 4 articles that show us where we're headed in artificial intelligence, robotics, medical technology, sustainable energy technology, transportation advances, space research, physics. Wow, you name it. And most important of all, we're going to give you an oasis of positive news thanks to the world of science and technology.
Absolutely, and I'm looking forward to a lot of these, and I think the best place to start, as usual, is story number 1, and before we even get started, people will notice that, hey, Dune, obviously this will be Dune-inspired tech, but real quick, Ralph, what'd you think of the movies? The new ones, not the ones from the the 80s.
Yeah, well, the new ones, the first of the new ones, I loved it, and I really want to see the second one. And I'm Mr. Cheap. I'm waiting for the second movie to make it onto the streaming services, whatever, Netflix and so forth, so I don't have to pay, $15-16 to go to the theater. But I did love the first of the new ones, and I thought it was great.
I was lucky enough to see both of them in theaters, and
nice.
The second one lives up to what the first one did. So
good,
you're in for a treat. But
good.
Hey, everyone else, you're in for a treat, because you may notice that Dune is like a lot of, kind of sci-fi fantasy kind of thing, full of tech that, like the tricorder and, tractor beams and lasers and stuff. Eventually science finds a way to kind of get it done, and Dune might not be any different. So, Ralph, story number 1.
Yes, this comes from Engadget.com. And the headline here, which I just loved and immediately drew my attention, Dune-inspired spacesuit recycles astronauts' urine into drinkable water. Okay, that's pretty cool. And in the show notes at computeramerica.com, folks, will have lots of links, pictures, and so forth, especially if you're listening to us as a podcast only. I really encourage you to come out, look at the show notes, get the links if you want to dig down deeper, because we're going to look at 4 articles. And what Ben and I do is we just give you the highlights of these articles, just enough words to get the main message through, but to get to the details, get the show notes. So with that said, let's get into the story. So here we go. The traditional NASA spacesuit design has been in circulation or use since the 1970s and only has an absorbent polymer to catch astronauts' urine. Basically, folks, a diaper. This outdated waste system has also led to hygiene and medical issues like urinary tract infections and gastrointestinal problems for astronauts.
I had no
Yikes.
idea.
Since the 1970s. Come on, guys. Anyway, here, a new spacesuit designed by scientists at Weill Cornell Medicine and Cornell University, inspired by Frank Herbert's Dune that Ben and I were referring to with the movies, could make spacewalks longer and less disgusting by recycling expelled urine in a special filtration backpack. Now, right now, I've only seen sketches, not a lot of detail. In the Dune series, these suits are referred to as still suits. STILL suits run together, still suits, which can absorb and purify water lost through sweating and urination and recycle it into drinkable water. So that's what's going on in the movies, and that's what inspired these scientists. The study's lead author and research staff member, Sophia Etlin, in a press release noted that the new still suits have a vacuum-based external catheter leading to a combined forward-reverse osmosis unit that astronauts would carry on their back. And a little side note, remember that forward and reverse osmosis technology plays a crucial role in water treatment and desalination processes. So this is pretty cool stuff, Ben.
Mm-hmm. Yeah,
now the suits were. Yeah,
and I just want to say that I don't know. I am still blown away by the fact that the spacesuits themselves, like water, humans need water pretty regularly. I'm surprised that the old ones based on the 1970s, still cause so many problems even today. So I'm surprised that we haven't come up with a better solution. But hey, this could be it.
Yeah, could be. And it is all with an eye toward future space missions, which we'll get into right now. Mm-hmm. The suits were designed with future NASA space missions in mind, including Artemis 2 and Artemis 3 missions that will orbit the moon and touch down on its south pole in the next 2 years, hopefully. Goes on to say NASA and Axiom, that's AXIOM Space, so NASA and Axiom Space have already approved a spacesuit design for its moon missions, but it looks like this new filtration system could be added to them. That's kind of a neat thing that this could be added. It wouldn't mean a complete redesign. The still suits can also be used for the manned Mars space mission in the early 2030s. Wait a minute. For me, at least, I said, time out. What is Axiom Space? Now, this is an example of what I do to add to these articles, which is all in the show notes. I said to myself, Axiom Space doesn't ring a bell to me. Who are these guys? Well, Axiom Space is the leading provider of human space flight services. They operate end-to-end missions to the International Space Station while developing its successor, the successor to the ISS, called Axiom Station, and building next-generation spacesuits for low Earth orbit, the moon, and beyond. And by the way, in the show notes, I have a link to Axiom and Axiom Station, and that's fascinating in its own right. So please get the show notes and check that out. And then to wrap this little story up, the research and design teams from both schools published a paper of their findings in the scientific journal Frontiers, and we have a link to that as well if you want to super geek out and dive in deep to this new system.
It's always like a little bittersweet to hear they're already planning on not just decommissioning the International Space Station, but of course to build its successor. I mean, like, it's cool. I imagine it's like still using your old beat up car that still runs and gets you to work, and then you go out and you get a brand new car. Like, I'm sure that the upgrades that, the difference in technology from the 70s and the 80s, yes. I think the International Space Station was started like in the 90s or something like that. But anyways, upgrading from that to a modern electronic and modern mechanics, it would be a huge upgrade to the International Space Station. So.
Yeah, you're right. And in fact, again, I encourage you readers like me, I wasn't familiar with Axiom and Axiom Station. Check this out. That's a nice side benefit of this first story.
Yep. And I'm not sure how involved Boeing will be after what's happening over there. Those astronauts are getting an extended stay, so that's fun.
Oh yeah, being in the Northwest, I'm in the Portland, Oregon area, but our cousins up north with Boeing, it's just a tragedy what's going on, and hopefully things will turn around with the new CEO, and we'll see.
There's some headlines in the past couple of weeks that are hopeful for Boeing because things have not been going the best for them. But either way, so Boeing out of here. Story number 1 out of here. Very cool still suits. Story number 2. Let's go ahead and just kind of skip on over here. And this will be or not skip, but leap, a scientific leap. And, my mother loves to garden. I hate to garden, but I'm the one who has to work the shovel. So I'm often out there digging in the dirt, fertilizing the plants, doing all the weeding, doing all the mowing, doing all the yard work. And Ralph, sometimes I think, nature needs to do nature better, because it takes so much effort and work to keep a well-maintained garden. Not a fan. But hey, story number 2 might have, some, maybe not for the everyday gardener, but some solutions for better plants.
Yes. This is a story that reflects the world of agricultural technology, or ag tech. This comes from a very interesting outlet called Anthropocene magazine. Really interesting. Headline was "A Scientific Leap Towards Smart, Self-Watering, and Self-Fertilizing Soils." Wow. Irresistible headline, right? And again, we have the links in the show notes. So here we go. Self-watering, self-fertilizing soil is now a step closer to reality. Scientists at the University of Texas at Austin have developed little beads called hydrogels that can capture water from the ambient air and use it to irrigate soil, while simultaneously dosing the surrounding plants with nutrients too. And time out. Ben, over the past several years, we've seen some other similar stories where it had to do with irrigation and trying to figure out ways to irrigate soil more effectively. What they've done here is improve upon that technology, but also add the bit about nutrients, fertilizing at the same time. This is what makes this story really kind of a special breakthrough. The study from the University of Texas, published in ACS Materials Letters, I love the names of some of these journals, it's really kind of geeky, is the latest step in a research project that has been advancing the development of hydrogels for years. Now, the gels are made from a matrix of polymers that are hygroscopic. That's hygroscopic, hygroscopic, meaning they absorb water. In this case, from vapor in the air, swelling as they go. And the hydrogels are designed to release this liquid load, water, when triggered by certain stimuli, including changes in soil pH or temperature. This is really great.
Interesting.
Previous research from the University of Texas lab has already successfully shown that the gels can capture moisture from the air even in dry conditions. That's such a key point, even in dry conditions. We know too, Ben, from water generating systems we've talked about in the past that can even work in the desert, because no matter how hot, how dry, there's still some measure of moisture in the air that can be captured, which I always find kind of hard to believe. So again, they've shown that they can that these gels can capture moisture from the air even in very dry conditions, possibly helping agriculture to spread to arid landscapes, which in a world desperate for more food, this could be a big breakthrough. And what's new and unprecedented, as I alluded to earlier, in this latest round of research is the addition of calcium fertilizers to the gel's polymer matrix. Okay, so now we're going to talk about what they did to test this, to see how well the newly developed hydrogel, they call it hydrogel 2.0, works in soils. The researchers ran a sequence of experiments, which for starters measured the pace of water and fertilizer release. In experiments, they infused the air with differing levels of humidity ranging from 30 to 90%. So this was all lab-based testing. Under high humidity conditions, they found the gels not only absorbed a substantial amount of the water vapor in the ambient air, but gradually released almost all of it over a 4-hour period, triggered by 40 degrees Celsius temperatures. That would be 104 degrees Fahrenheit. So that's pretty warm, of course.
Yeah.
Although not that strangely warm these days with climate change, right?
True.
Yeah, cool stuff. So next, they were curious to see how effectively the gels delivered the fertilizers. As it turns out, the calcium fertilizer they used is also hygroscopic, meaning it enhances the gel's water absorbing capacity. What? The fertilizer is not only going to help fertilize the soil, but the type they used was hygroscopic. So it was helping the basic gel do its job of grabbing moisture from the air. Wow. So the gel contacts, so when the gel contacts water vapor, the water-loving fertilizer gets dissolved within, further hydrating the gel and the soil accordingly. Wow. Good stuff.
Huh. Yeah, and Ralph, I don't know how much you garden, but whenever I'm out there in the garden, we use this stuff called soil moist. You put it in, you dig your hole, you put in soil moist, and it's the same material, Ralph, that's inside like baby diapers, essentially, that absorb moisture. And it's the same material, and you throw it in the bottom, and it, whenever it rains, it collects it, and it kind of spreads out the moisture over a longer period of time. It sounds like the exact same thing, if I'm being honest. But what they're doing, and as you noted in the notes, they added fertilizer to it, and that made it even more so, able to keep the moisture. So it's not a completely like unknown technology, which is good. I mean, to iterate on what is working well is always a great breakthrough.
Right.
But then to add fertilizer to it, hopefully could bring a lot more crops and a lot more healthy planting to a lot more areas. So,
and
cool.
as the article pointed out, making agriculture possible in arid areas that heretofore might not have been very good candidates. So that's another wonderful benefit of this potential technology.
Absolutely, being able to plant more and more places is kind of key to everything. So there you go. Story number 2, really, really good stuff. Story number 3. How many times have you seen a cartoon, and especially if it's underwater, and the character reaches over to an electric eel and kind of uses it to light a light bulb or do something? Electricity and eels have always been kind of associated in kind of modern television, modern cartoons and things like that. Well, the inspiration goes a step further, because it's not just a cartoon. This is a fun one, and Ralph, you found another battery technology.
Yes. And of course, another headline I could not resist. This comes from techexplore.com. The source for this one is the University of Cambridge. Headline: soft, stretchy, jelly batteries inspired by electric eels. Irresistible headline. I had to know more. And there's some great pictures in the show notes. Again, if you're listening to us as a podcast, come out to computeramerica.com and get the show notes. So here we go. Researchers at the University of Cambridge have developed soft, stretchable, they call them jelly batteries, that could be used for wearable devices or soft robotics, or even implanted in the brain to deliver drugs or treat conditions such as epilepsy. Wow. Okay. The researchers took their inspiration from electric eels, which stun their prey with modified muscle cells called electrocytes. Now, like electrocytes, the jelly-like materials developed by the Cambridge researchers have a layered structure. They call it like a sticky Lego that makes them capable of delivering an electric current. And I want to stop for a second. Again, the show notes are so important because we're just giving you the highlights. There's so much technology behind this story that you can learn about if you come out, get the show notes, and look at the links.
Sure.
Going on, though, it says the self-healing, ding, ding, self-healing jelly batteries can stretch to over 10 times their original length without affecting their conductivity. Wow. The first time that such stretchability and conductivity has been combined in a single material. The first time, folks. Wow, I just love it. Going on, the jelly.
And by the way, just real quick, just looking at the picture again, it's almost like a gummy worm. Just how stretchy it is. That it really shows. The pictures. Very nice.
Yeah, that is cool. The jelly batteries are made from hydrogels. Sound familiar? The 3D networks of polymers that contain over 60% of water. The polymers are held together by reversible on-off interactions that control the jelly's mechanical properties. Again, you need to dive deeper into the research papers to understand that. The ability to precisely control mechanical properties and mimic the characteristics of human tissue makes hydrogels ideal candidates for soft robotics and bioelectronics. However, they need to be both conductive and stretchy for such applications. Hmm. The properties of the University of Cambridge jelly batteries make them promising for future use in biomedical implants since they are soft and mold to human tissue.
Hmm.
In addition to their softness, the hydrogels are surprisingly tough. They can withstand being squashed without permanently losing their original shape and can self heal when damaged. The possibilities here are overwhelming. Once again, if you want to learn more in the show notes, I have a link to their official scientific paper published in the journal Science Advances. Amazing stuff.
It's really cool, and I hope that, and I know that not all battery technology is interchangeable, but I couldn't help but think, Ralph, like, think of Tesla cars. If you've ever driven in one, or at least you've ever heard of these things,
Sure.
if they get in like a fender bender, if they get in some kind of head-on collision or whatever, like, like, electric cars are cool. You should definitely get one. I like them. But be thankful that you don't have to pay to repair one, because, Ralph, like, the stability of the giant lithium battery that you're sitting on whenever you drive those things, even the slightest impact or even the slightest accident could cause you to have to replace your $15,000-$20,000 battery unit, because it fractures, it cracks, it's very rigid, and any impact could cause, you don't want it to barbecue you. So anything to kind of reduce that, to reduce the rigidity and kind of add flexibility to it might actually go a long way to solving a lot of the issues with that. But obviously not all battery technology is interchangeable, but still, this is promising in a lot of different ways.
Well, yeah, and it's fun to speculate on something like that for the future. At this time, what they're talking about are very small things that could be, small, little flexible batteries, but nonetheless a big, important step forward, especially for the world of soft robotics, which is more and more and more becoming a big deal. So cool stuff.
Yeah, for sure. So there's that story, and also you can think of things like pacemakers as well. But hey, I digress. That's story number 3. Story number 4. I don't know why pacemakers are on my mind. Hey, story number 4 is about heart bypass surgery, so maybe that's a reason. Story number 4, and this is not AI. Sorry, everyone. I know you're just begging for another AI story, but no. Story number 4 is going to be about 3D printing, and 3D printing, like, organs and things that people really need, has always been, like, on the cusp, and still, obviously, what Ralph likes to talk about is research, which is very, very good, but 3D printing human stuff is always, like, we want to do that so bad, but we just can't quite get there. It looks like story number 4 is research leaning in that way again.
It sure is. And folks, if you're new to the show, what we often do on our Friday show is end with something from the world of medical and medical science technology. And the headline here comes from an outfit called scienceblog.com. The headline is 3D printed blood vessels, a game changer for heart bypass surgery. I had bypass surgery in 2011, so this was very personally of interest to me. We've got some great links and great images, but first, a little background. In coronary artery bypass grafting, surgeons typically harvest either the radial artery from an arm or the saphenous, I hope I'm saying that right, vein from a leg. These healthy blood vessels are then used as grafts to create new connections, bypassing blocked coronary arteries and restoring blood flow to the heart. So that's what bypass surgery is all about. But again, the key here is typically you harvest healthy veins from other parts of the body to replace the clogged and damaged veins serving the heart. Okay, so now to the news. Researchers at the University of Edinburgh have developed a new method to create artificial blood vessels using 3D printing technology. These gel-like tubes, I think gel seems to be a theme today. These gel-like tubes they have created closely mimic the properties of human veins and could revolutionize heart bypass surgery, potentially improving outcomes for thousands of patients each year. The innovative technique produces strong, flexible vessels that could replace both human and synthetic veins currently used in bypass operations. And to your point, Ben, it's not so much that the world has never seen synthetic veins before, but they're done with a different technology and so on. So this advancement addresses long-standing challenges in cardiovascular treatment, offering a promising alternative that may reduce complications and improve patient recovery. The research team, led by the University of Edinburgh School of Engineering, employed a two-stage process to create these artificial blood vessels. So first, they used a 3D printer equipped with a rotating spindle to produce tubular grafts from a water-based gel. Next, they then reinforced these grafts through electrospinning, which is fascinating in its own right, a technique that uses high voltage to create a coating of ultra-thin nanofibers made from biodegradable polyester molecules. Super geeky stuff here, folks. The resulting artificial vessels demonstrated strength comparable to natural blood vessels. Moreover, their flexibility suggests they could integrate seamlessly into the human body. Wow. And Ben, you're going to love this next part here. The researchers can produce these artificial blood vessel grafts in a wide range of sizes, which is no mean trick when you're talking about 3D printing. So they can make them from 1 to 40 millimeters in diameter, making them suitable for various applications in vascular surgery. So this goes beyond just treatment of a heart bypass. Now, like so many of our stories, and this is something that Ben and I like to stress, we're often talking about early research, new ideas. And it says here, however, it's important to note that this technology is still in its early stages. The next phase of research will involve testing these artificial blood vessels in animal models at the University of Edinburgh's Roslin Institute. But a very encouraging way to end the official 4 stories of today's show.
Yeah, for sure. And it's it always makes me laugh, like, you know, even with all the high technology that we talk about, even with all the advancements that we talk about, the human body still tends to out-innovate even what we can do in a lab. It's, human blood vessels are themselves so common, obviously, but obviously so unique and hard to replicate. So very, very cool stuff there. Okay, so story number 4, and like you said, that's about it. Unless you're following along in the show notes, which are available on the site if you've been following along. There's more, and you're like, but wait, Ben, keep going. No, we try to keep the show as concise as we can, and today's show is plenty concise. So if you want to find out more, you can head on over to the website, and you can see them there. But for the nice folks out there who may be just listening, Ralph, let's just give them the headlines, and if you want to find out more, again, come on out to the site, and we can find the links.
Yeah, we call this, Ben and I call this section of the show honorable mentions, where we're just going to give you the headlines and source, let you come out and get to the show notes at computeramerica.com. But our honorable mentions this week, first, this AI movie camera transforms films into whatever you can imagine. Whoa,
there's your AI story.
There it is. This comes from techradar.com. Please check this story out. It's fascinating. The next honorable mention from techexplorer.com, headline, Intelligent Skin for More Precise Communication and Near Field Sensing in Robotics. The near field sensing is particularly interesting. We've seen so much research in artificial skin for robotics, but the near field sensing is the thing that caught my attention, again, from Tech Explorer. Check this one out. That's a great story. Our next honorable mention, headline, researchers create world's first anode-free sodium solid-state battery. This comes from techexplorist.com. That headline alone is loaded with a lot. First anode-free sodium solid-state battery. Wow. Great one.
I don't know much about batteries, but I always assumed anode and cathode. You kind of need both. But there you go. Story number 3 in the honorable mentions.
It was a really loaded headline. I couldn't resist. And the last honorable mention for this show is from the University of British Columbia, Oregon, so our neighbors to the north here. Good for you guys. A headline, Super Black Wood can improve telescopes, optical devices, and consumer goods. How can you resist this headline? What? Super black wood? How could that have anything to do with telescopes, optical devices, and consumer goods? Got to read it to find out. It's a fun read and a really good way to end today's show.
For sure. Definitely reminds me of, the one you did earlier about soil and agricultural tech.
Yes.
Even low tech things, even things that you think are as far from technology as you can get, can still be high technology. So, ladies and gentlemen, I want to thank Ralph for, of course, finding these stories, bringing them on the show, and discussing them with us. And everyone out there, I want to thank you for tuning into the program, listening, and checking out the show notes. So, with that being said, I hope that you had fun and you do something fun this weekend. Everyone, we will be back next week with more stories. And as always, computeramerica.com, you can find links to everything. And until next time, have a great day. Thank you so much. Catch you next time. Bye, everyone.